to talk about camouflage. So what I've been doing with the kids is I've been making them turn around, and we've been like spreading these out and making them pick which one they can see the most. So like they'll turn around, they'll close their eyes, and then we'll count to 5 and then turn around and they'll pick first one they see. And the one they don't pick is the one that's best camouflaged. So here it's going to be the pink one. And then we talk more about Darwin here. See, he's kind of the school mascot. Everybody seems to know Darwin. And Darwin is a bearded dragon. As you see, he likes to climb. He's from West Australia. Hi, Darwin. And then we asked them like where they think he'd be most camouflaged, which is the desert, and what he might like to eat and how he preys and goes about that. And then Rayleigh will go around and ask them questions about like what kind of prey they eat and how they camouflage themselves and what kind of animals use camouflage. And that's about it.
Hey Wave, it's Asias and I'm here with my partner, Chloe. And we're here to teach you all a little bit about hydrophilic and hydrophobic materials. This is a part of chemistry. So first we have this magic fish. Take it out of the bag, you put it in your hand, and you watch it curl up. Okay, so it's curling up in my hand, but when I put it on the table, it stops moving. And why do we think that is? Well, there are many answers that you can use to explain this, but the main reason is because this material is made out of a hydrophilic plastic. And what hydrophilic means is that it's water loving. The materials that make up this plastic love water. They want to get close to water. Now, the opposite of hydrophilic is hydrophobic. Water hating materials. They hate water. They don't want to get close to water. They'll do everything they can to not get close to water. So we have a little experiment. We're going to be working with 2 different types of sand. We have this regular sand, and then we have this blue mystic magical sand. So we're gonna look at a regular sand first. This is just sand you can find on the beach. Pour it onto the spoon, and we're just gonna watch what the water does when we put it onto the sand. Ta-da! The sand absorbed all of the water that we put onto it. So the sand loves water. It wants to get close to water. That's why it absorbed the water. And what we call this is hydrophilic. It's water loving. Now we have this blue mystic sand. Watch closely to what it does when we pour it onto there. Yes, okay, so the water is staying away from the magic sand. It does not want to get close to the sand. It absolutely hates the sand. And that's what we call hydrophobic materials. Recap, we have hydrophobic materials, we have hydrophilic materials. Hydrophobic means you absolutely hate water, you don't want to get close to it. There are things within the material that makes it not like water. And the opposite of that is hydrophilic. The materials in the water absolutely love water. The materials in the chemicals in the material absolutely love water. And that's basically it. Thank you all so much for watching.
Hey everyone, it's Maple and Vic. And we're here at Science Carnival today to do the magic milk experiment. So I'm going to narrate and Vic is going to show you how to do this experiment. Let's go. Okay, so right now we have a dish of milk and Vic is going to add a couple drops of food dye to it. Blue, green. Yeah, we're just going to add a couple colors right now. Now that Vic has added a drop of food coloring, she's going to add a drop of dish soap. Whoa, I don't know if you can see it, but what's happening is the colors spread apart in the dish. So this happens because milk is made of fats and the dish has water in it. So the hydrophobic ends of the fat are gonna be attracted to the water, and the hydrophilic ends are gonna go away from it. So it makes the colors spread. So yeah, that's our experiment. Hey guys, I'm Harshika, and I'm here with Katie and CJ. And today, we're gonna be doing a static electricity experiment. Okay, so what is electricity? Electricity is another form of energy. And energy can be used to power things, correct? And so, we're gonna see how that works in our experiment right here with the circuit. So, pretty much, CJ is going to power the circuit by turning the generator. And so pretty much what's happening is that CJ is using the generator, and the generator powers the circuit using energy, right? And so if we disconnect parts of the circuit, we'll see that the circuit does something a little bit different. And it only powers one light bulb. Next, we have a regular magnet here, right? Regular magnets, you know, magnetize, they can pick up metal things, right? But here we're gonna make our own magnet, right? And so what Katie has right now is just a metal rod. And so right now she can't pick up things with this, right? But CJ is gonna magnetize it so that she can. Now, we're going to do a little different experiment. Okay, next we have this battery, and we're going to use this battery to actually power this crank. So we're going to connect it together. Okay, and it powers the crank. Oh my god, that's crazy. Okay, so that's another one. Next, over here. Now, we can use this device to create static electricity. So pretty much we're gonna get it ready. And Katie is gonna crank it. Okay, and here you can see the static electricity. Oh my god, that's crazy, right? And now we're gonna see what happens when we put this paper in between. Is it set on fire? No, it does not set on fire. That's crazy, guys. It's because this paper insulates the electric shock. Oh my god. Okay, now, since we've learned what circuits do, right? We're gonna make our own circuit now, okay? And so Katie's gonna start it off. I'm gonna connect here. CJ's gonna connect to me, and then back over there. And we have our circuit, guys! That's all, guys. Thanks for watching.
Hey Wave, it's Nathan. I'm here with my friend Geoffrey, and today we're going to show you guys about Waterlock. So I have right here, I have just a regular cup. I'm going to put some water in it. It's just regular water, do a little sip, and then I'm going to pour some water in it. And then if I do a little swirl, it's just water in there, right? And then I'm gonna check to make sure this is water. So Geoffrey, can you lean down? Let's poke a little hole in it. See what happens. Yeah, poke a hole. Lean down a little bit. If I poke a hole right through it, boom. Whoa, let's go completely through. He's not wet. It's kind of magic. Let's poke another one just in case, just to see. And I'm gonna need to stay down there because we gotta pull him out.
Damn, that's crazy.
Then poke another hole through it, then boom. Whoa. Well, maybe the nails are just keeping the water in there. So let's pull it out. It's not. Let's pull it out. There's no water in there. Let's check and see what's in there to see if anything changed. So if you look in there, there's some gel. And it's because in there we had this thing called Waterlock. And this Waterlock is this powder, and it locks in the water. It got all the water and locked it in, and it made a little interaction, and it's kept it in there. This can absorb 500 times its amount in water. So like one little spoon of this can take 500 spoonfuls of water and make this little gel. We have the gel in a little bag here. This is what it looks like in a bag. It's like real squishy. It's kind of just like any kind of gel. And so basically to get it out, it kind of has to interact with salt to like unwaterlock it basically. If you want to have Geoffrey go ahead and put some salt in there. Let's poke a hole in the bottom so we can actually see it. And then we're gonna just mix it up. Let's put a lot of salt in there just to make sure. And let's mix it up, Geoffrey. Mixing and mix. And it'll just mix, and then the salt is interacting with the Waterlock to make, boom, it turns it back into water. It's just like salty water. And basically, we use this. It is a sulfate polyethylene, and we use it in diapers to absorb like pee and stuff. So you know, if you were a little baby, you should definitely like thank Waterlock for saving you. So, Waterlock, it helps you and babies. Thank you guys so much for watching.